Hello everyone and welcome back to the CodeChef platform. Today we are diving deeper into variables in C++. Not just how to use them, but also how to work with them efficiently. We'll cover everything from multiple variable declarations to typecasting, both implicit and explicit. And we'll also look at variable scope, block level and global level. Basically, by the end of this video, you'll know how to manage variables in C++ like a pro. The first topic in variable operations is multiple variable declaration in C++. In C++, we can declare more than one variable of the same data type in a single line instead of writing each declaration separately. This helps make our code shorter and cleaner. Coming to the syntax of how to declare multiple variables in a single line. So we first write the data type and declare the variables with variable name like data type var1, var2, var3 and so on, and then a semicolon. Well, we can also assign values while declaring. How to do that? For example, the data type, then var1 is equal to its value, comma, var2 is equal to the value of variable 2, then var3 is equal to value of variable 3 and so on. Now let's go to the CodeChef platform to see an example for declaring multiple variables in C++. The program objective is storing and displaying exam score, and this is the desired output. Math score :85, science score :90, English score :78. Coming to the code, hash include IOStream using namespace std int main. Now inside the int main, int math score is equal to 85, comma science score is equal to 90, comma English score is equal to 78, semicolon. So here if you see, int is the data type and this is the data type for all the three variables that we have declared in this single line. Now the first variable that we have declared is math score. The value that we have assigned to math score variable is 85, comma, now the second variable name is science score and the value scored in science score is 90. Lastly, English score, this is the third variable and its value is 78, semicolon. Now cout insertion operator in double inverted comma math score. So math score colon, this will be printed as it is. Now insertion operator and then variable math score, so its value will be printed in the output, and endl to shift the cursor in a new line, semicolon. Then cout in double inverted comma science score colon and then insertion operator, then value of variable science score and again endl. Then cout insertion operator in double inverted commas English score colon and then again insertion operator, now value of the variable English score which will come from here 78 and again endl. Then return 0 and the main function ends here. Now let's click the submit button to check its output. Okay. Math score :85, science score :90 and English score :78, which is exactly similar to the desired output. So this is how we declare multiple variables in a single line in C++. Now the next topic is typecasting. Before we get on to the types of typecasting, let's discuss its definition. So typecasting, also known as type conversion, means changing the data type of a variable from one type to another. There are two types of typecasting. First is implicit, second is explicit. Let's start with implicit typecasting. When the compiler automatically converts one data type to another during an operation, it is called implicit type conversion or type promotion. It happens without any user involvement. Now if we see the conversion hierarchy, so when different data types are used together, C++ promotes the smaller type to the larger one according to this hierarchy. For example, the smallest data type is bool. So it will be converted to char. Char will go to short. Short can be converted to int. Int can be converted to long. Long can be converted to float, and float can be converted to double data type. For example, you can assign a char value to a short to an int, and so on up to a double. Now coming to the syntax, large data type, then variable name is equal to small data type value. So this is how we do implicit type conversion. Now let's have a look at one example of implicit type conversion on the CodeChef platform. Here the program objective is converting age from int to double, and the expected output is integer age colon 25 converted age in brackets double colon 25. Coming to the code, hash include IOStream using namespace std, then int main. Now inside int main, int age is equal to 25 semicolon. So here we have defined a variable int age. Here age is the name of the variable, int is the data type, and 25 is the value assigned to variable age. Then double age in double is equal to age semicolon. So here we are doing implicit conversion from int to double. So target data type is double, in which we want to convert the variable's data type. Then age in double, this is the name of the variable, assignment operator and age. So now what will happen? The data type of variable age will be converted from int to double. Then cout in double inverted commas integer age colon, and then insertion operator age, which will take the value of age variable, then endl to insert the cursor in a new line. Again cout, then in double inverted commas converted age, then in braces double colon, then insertion operator age in double, and then endl. Return 0 and main function ends here. Now let us see what is the output. Integer age colon 25. So from here integer age colon, this is printed as it is, and the value of variable age is 25. Then converted age in brackets double colon 25. So here converted age double colon, this is printed as it is, and age in double. This because we have done type conversion here, so the value of variable age is shifted to age in double. So here also we have got output 25. This is how we do implicit type conversion in C++. Explicit type conversion. Explicit type conversion, also known as manual typecasting, is when the programmer intentionally converts one data type into another. The compiler does not do it automatically. You decide how the conversion should happen. It's useful when you want to control how values are converted. For example, converting a float into an int and removing the decimal part. Coming to the syntax, target data type variable name is equal to the bracket target data type and then value and semicolon. Next topic is variable scope. Now, what is variable scope? So, scope of a variable means the region of a program where that variable can be accessed or used. In C++, every variable has a specific scope. It can be global or block level depending on where it is declared. Let's start with block level scope. A block in C++ is defined by curly braces. A variable declared inside a block, that means inside curly braces of a function, loop or conditional statement, has block level scope. This means that the variable can only be accessed inside that block. It is destroyed once the block ends and it cannot be used outside the block. Now let's go to the CodeChef platform and see example of a variable whose scope is block level. The objective of this program is bank transaction, and the expected output is age inside the block :25. Coming to the code, hash include IOStream using namespace std, then int main. Now inside curly braces, you can see another set of curly braces. This is a block of code, and now whatever variable we declare inside this block can be accessed and used only within this block. Okay. Int age is equal to 25 semicolon. Cout insertion operator in double inverted commas, age inside the block colon, and then again insertion operator, then the value of variable age will be printed, and endl, then bracket close. So this block is over. Now outside the block returns 0 semicolon and the main function ends here. Let's run the code. Age inside the block :25. So what we are doing, we have made a block of code using curly braces. Inside this block we have defined this variable and we have accessed it to print the value of age, and this is how we got this output. Global block scope. A variable declared outside of all functions, blocks or classes in C++ is called a global variable. Talking about the scope of global variable, it is accessible throughout the program in all functions and blocks after its declaration. And talking about its lifetime, it exists for the entire duration of the program. Let's see an example of a global scope variable on the CodeChef platform. The title of the program is Global Scope Variable, and the expected output is account balance before withdrawal :1000, account balance after withdrawal :700. Let's get on to the code. Hash include IOStream, then using namespace std. Then we have declared a variable int balance is equal to 1000 semicolon. So this is a global variable. Why? Because it is not declared inside any block, any curly braces. In fact, the main function is also starting after the declaration of this variable, and therefore this is a global variable. Then int main. Now inside int, cout in double inverted commas account balance before withdrawal, then insertion operator balance. So here we are accessing this variable balance to print its value, which is 1000. Then endl to shift the cursor in a new line. Now balance is equal to 700. So here we have modified the value of the variable balance. As you can see, there is no data type written before variable name. So this is not declaration to a new variable, but we have simply updated the value of variable balance from 1000 to 700. Then cout in double inverted commas account balance after withdrawal colon, and then again balance. So now the updated value of variable balance will be printed, and endl. Then return 0 and the main function ends here. Now let us run the code to see the output. Account balance before withdrawal, then the value of this variable is 1000, and account balance after withdrawal, and then :700 because the updated value of variable balance is 700. It also matches the expected output. This is how we declare variables with a global scope in C++. So today we explored multiple variable declarations, learned about typecasting, both implicit and explicit, and saw how variable scope works from block level to global level. These are essential tools to make your C++ program cleaner, smarter, and more efficient. Remember, practice is the key. Try these concepts on the CodeChef platform to polish your coding skills. Thank you so much for watching.